This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. In this video, I'll complete work on the rectification and filtering component. I've cut a series of wires for the rectification filtering board output. Those wires now need to be stripped. And now I need to drill holes for the wires. The holes are a little bit bigger than pre-drilled holes on the strip board, using number 55 gauge drill bit and a very slow rotary drill speed. Now insert the wire and bend it, try to keep it in place, apply some liquid flux, and apply a soldering iron to the joint between the wire and the strip, and then solder it. And repeat this over and over again. Because all of this is out in the open, it's a little easier to do this than to solder the inputs, which necessarily have to be close to the transformer secondaries. I'm using a solder flux pen, as I do for all work on printed circuit boards. It's more convenient, less messy. I'm using a very small chisel tip for this. I try to keep the chisel tip about the width of the strip. By and large, I use nothing but chisel tips. I use a large one, I think 1/4 inch, and then a relatively small one. And there's something in the middle. I have a chisel tip somewhere around there, which I never quite use. Now the output wires on the right side are destined for the 0 to 20 volt regulators. The middle wires, which are red, white, and blue from here, actually orange, white, and blue, are for the +20 to 0 to -20 regulator. And black and red wires will ultimately wind up feeding the digital external power supply, +5 and +3.3. Next, I'm going to use epoxy glue to provide strain relief. I find if I don't provide strain relief on these things, and I'm forever taking them apart and putting them back together again, what happens is solder creeps up the wires under the insulation sometimes, and the wires can get fragile, they can break, and before you know it, you've got an intermittent problem that is difficult to determine because there's a broken wire underneath the wire insulation. Now I'm using heat shrink tubing after twisting these wires. I'm twisting the wires really just to keep them together. There's probably no reason other than that. There are some AC component, because there is ripple voltage coming out of the rectifier filter component, 120 hertz ripple, but at relatively low amplitude. And I doubt that it's going to interfere with surrounding circuitry, but there's no reason why not to twist the wires. It provides some additional inductance. This heat gun, also called a surface rework station, is relatively low temperature, 150 degrees. Now I'm done with the outputs and I'm twisting wires coming out of the toroidal transformer secondaries. I have to remember to put the heat shrink on first before I solder it, not after, which can lead to annoying problems. The connections of these things are documented in the circuit diagram as part of the documentation for this project, available through the corresponding website. Right now, I'm working on the 0 to 20 volt rectifier filter component, which will feed the corresponding voltage regulator. And this is more than a little tedious. Now that that component is done, I'm going to apply some epoxy glue as strain relief. I need to do this immediately after finishing the soldering so that when I go to twist and turn the board the next time for the next set of wires, I'm not going to cause damage to the previous set of wires. Now let's dress up these wires and heat shrink tubing. It's a reasonable wire attachment. Could have done better, but that's always the case. Now, on the input side, the wire twisting really does make a difference because I'm dealing with voltages that are 25, 30 volts AC, and they could generate electromagnetic interference. And so twisting them and paying attention to the routing of these wires is essential. Well, not essential, but desirable. It's amazing how these wires have a mind of their own and insist on twisting and turning every which way but where you want them. Process is the same. We're still working on the secondaries that will feed the plus 20 to 0 to minus 20 rectifier filter components. Apply the soldering iron to the wire and the strip, then apply the solder after having first applied liquid flux. And now we're applying epoxy glue to the wire to circuit board joints. This is that 5-minute epoxy that sets within an hour to 24 hours. It becomes useless in terms of working it after 5 minutes. I guess that's what they mean by that. And now applying heat shrink tubing to keep that set of wires together. I wish those wires were twisted a little tighter than they are. I suppose what's really important is just keeping the wires the same length and close together so that a magnetic field generated in one direction is being countered by the same field in an opposite direction based on the positioning of the wires. Applying the heat shrink tubing to the last of the toroidal secondaries, and this is going to go feeding the external digital supply. Stick a wire through the hole, try to crimp and bend the wire in place, apply liquid flux, and solder. The idea is to heat up the wire and the strip, not the solder. Let the wire and strip heat up the solder indirectly. And now we're done with that leg of the process, and I'm applying epoxy. And now heat shrinking the digital supply rectifier filter component. Now all the wires are soldered in place. And next I need to mount the second board, the external rectifier filter board. Put a washer, then a lock washer, and then the nuts. And use a nut driver to tighten up on those nuts. And I want to make sure that there's sufficient clearance. After mounting the rectifier filter boards, I checked each output voltage and recorded it on the circuit diagram. The circuit diagram is part of the prototyping system design document, which is available from the corresponding website, along with other documents, references, and links relevant to each video. You can download the design as a Visio file or PDF file, or view the PDF online. In this video, I connected leads from the toroidal transformer secondaries to the external rectifier filter board inputs. I then soldered wire leads to the board's outputs. I mounted the board to the enclosure, and I checked output voltages from each of the rectifier filter component outputs. We will be doing something other than electronics for a while. After a 1-month hiatus, we will resume publishing eHobbyist blog. In that next video, I'll begin work on the voltage regulators. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.